Okay, so for this lab, you're going to need two things that you have prepared ahead of time. The first one is limp celery, and all you have to do to prepare that ahead of time is to leave it out for a couple of hours. We put it out on the patio today and let it lose its turgor pressure a little bit, or you can just leave it out overnight. So limp celery is the first thing you have to prepare before you start, and the second thing is salt water. You're going to want to put about 1/4 to 1/3 of a cup in some water on the stove with a parent supervision. Stir it until it becomes saturated so you can't dissolve it anymore. And you'll have a little bit more salt than what can dissolve, but preparing that and making sure that it's had time to cool off is going to be important for setting up this lab. So the first thing that you're going to do is add a couple of drops of food coloring to each one of your cups. So add food coloring. And this will help you to see the water move through the xylem in the celery, but also it'll help you to distinguish between your saltwater solution and your plain water. That's good. Okay. Now you already have 1 cup measured of salt water, so you can go ahead and just pour that into your cup.
All of it?
Mm-hmm. And you don't have to let all the salt go in because it's already dissolved in there. Okay. All right, and then put your food coloring into your blue food coloring into your cup. And 1 cup of plain water.
That appears to be a lot more water.
That's more water. You want to make sure the water is about the same. We had some of our salt water evaporate, so we're going to just make sure that you have about the same so that you're keeping your variables the same. There we go. All right. So the next thing that you're going to do is your xylem at the bottom of your celery is going to be damaged from it dehydrating. So you want to trim off the ends of your celery. Just a little bit off the end so that you have fresh celery. Is it all cut all the way through? You want to cut it through?
I think so.
You want to make sure you push on
Save
it.
this time.
Okay.
Definitely how you cut things.
All right. So if you have a scale, awesome. If you don't, that's okay. If you do have a scale, what you're going to do is mass your celery before and after your experiment. So your salt celery, put it on here on the scale. So 0.92 ounces is what's going into the salt solution. Okay, so put it in there. And now mass your next set. What does it say?
1.02 ounces.
Okay, 1.02 ounces of celery are going into the plain water solution. And then you're just going to leave it overnight and see how it changes and see what it looks like in the morning. That's it. Okay, next morning, let's look at our celery stalks and go ahead and describe them to me and set them on the paper towel.
Okay, so the blue one, there is blue in the leaves.
And what kind of water was that in?
This was the fresh water,
Okay.
and it goes up to where the water was. There was blue from.
Hold the celery stalk up for me again so we can get a good view of it.
There's
Okay.
blue in the leaves and blue up to where the water hit.
Okay.
The red ones are all wilted at the bottom, and there's only red up to where the water hit. There's no red in the leaves.
Okay, so the stems that were in the water are more wilted than they were yesterday.
Yeah.
But the stems that were in the fresh water
Are a
are
little
more
better.
turgid than they were yesterday.
Yeah.
Okay. So let's go ahead and mass those and see if they had any change in mass.
They are 1.41 ounces. So don't mind my notes.
So is that an increase or a decrease in
That is an increase.
or mass? Okay. So let's go ahead and mass the celery that was in the salt water now.
It is now 0.71 ounces.
And what was that yesterday?
It was 0.92.
So what happened?
It was a decrease.
Okay. So let's look at the xylem vessels. Again, we want to expose the xylem vessels. So you're going to want to cut off the part, so the bottom part that's totally blue, you want to cut that off so that you have some that's just exposed after that. Okay, now let's look at those. Are they still blue in there?
They're still blue right here.
Okay, so you can see that that blue water was carried up the xylem vessels to the parts of the celery. Now let's look at, see if there was a lot of water moving into the xylem vessels in the red celery. So again, cut off the bottoms.
Feels like a floppy noodle. It is pretty much white on the inside.
Maybe you try to cut that one again.
Yeah, look. The inside.
Okay, so what we're looking at here is water did not flow into the celery. We do have a little bit of celery color, just change, color change at the bottom, but that's just from the dye that was surrounding the edges of the celery. It didn't actually turn any of the celery red up here because water wasn't flowing into the celery. Water was actually flowing out of the celery due to osmosis, because there was a higher concentration of water even in the wilted celery than in the saltwater solution. This was about 75% water. And the celery, believe it or not, was about in the 90s, upper 90s, even when it was wilted and had low turgor pressure. So water in the 90% celery, that was the celery that was 90% water. We had 90% water here, 70% water here, and because of osmosis, the water was going to flow out to try to make the water levels equal on both sides of the cell membranes. Over here, there was a higher concentration of water because it was like 99% water, just a little bit of food coloring, which is also mostly water. But we had wilted celery, so we had kind of in the low 90% water of the celery. So the water flowed into the celery, made it more turgid and upright, and you can see there the evidence that the water actually flowed into the celery and increased the turgor pressure of the celery. Did you like this lab?
Yep.